Thanks, Alex. Thanks, Mutu, for the great introduction and organizing this event. It's really nice to be here. And yeah, as Alex and Mutu already said, I'm going to be talking about the commodity supply chain deforestation monitoring. But before I do that, first a little bit about Satelligence. So Satelligence, at Satelligence we use satellite-based monitoring insights to inform our clients about their supply chains. And these supply chains, they can be from, for instance, oil palm or cocoa or soy or any other agricultural commodity. And we actually believe that besides the technology, which is very important, that it's super important to have boots on the ground. You need to be in the places where it happens. So that's why we have local offices in Ghana, Tanzania, Indonesia, Bolivia, and soon also Brazil. Our clients are consumer good brands, traders, and NGOs, and we partner up with organizations such as Wageningen University in research and also the World Resources Institute. Okay, so that was a very short intro about Satelligence, and now let's get back to the webinar topic. And for me, this basically boils down to the following statement, which is how your neighbor buying peanut butter relates to deforestation in Indonesia. So let's say your neighbor wants to buy a jar of peanut butter, but she also wants to be sustainable. She wants to buy the most sustainable version and the most deforestation-free jar of peanut butter. But how is she going to choose? Because there's so many options, and nowadays there's a whole rows of them. And how are you going to decide? And I think you cannot really blame your neighbor for not knowing which peanut butter jar is the most sustainable or the most deforestation-free. Because often the companies that make these peanut butters, they don't fully know themselves. So how can you make sure that a peanut butter jar that you buy doesn't relate to something like this? So we at Satelligence, we believe we have a solution for this, and we do this by monitoring deforestation risk, and we monitor progress towards a zero deforestation commodity supply chain. It's a lot of words and it's a lot of monitors. And I don't necessarily mean these kind of monitors. What I do mean is a monitoring system that consists of three components for us. So the first part is the deforestation risk monitoring engine, which is really the technical backbone. How do we detect deforestation? Which satellite images do we use? Which algorithms? Which other data? But then how do we put this into context? Which other data do we add? And how can we combine that into a supply chain model? After that, you need to take some action. So this is also, we think, very important. So first up is the satellite monitoring. So an average day on planet Earth looks a bit like this. It's very cloudy. The Netherlands also, as it often is, but mainly also in the tropics, where it's very persistent cloud cover. And these are where these commodities are grown, such as oil palm oil, cocoa, and soy. But luckily, we can use radar satellite imagery that can penetrate through the clouds. And by using those images, we can monitor areas that are under persistent cloud cover. Another example is this. This is another cloudy example in Sumatra, Indonesia. And what we do is we combine the radar images with optical images and a long time series to get to what we call a forest baseline. So we know where intact forest is still present, we know where plantations are, and we know where other areas are that are of less interest, such as water, urban areas, etc. If we then overlay this with tree cover loss in the area, then you can immediately see that a lot of the tree cover loss that happens is actually within plantations, and it's not within natural forest. And of course, what is most important is actually these kind of changes that are occurring inside the natural forest. And what we do is we filter, and together with the client, we decide what are the highest priority areas that need to be looked at. Oh, I don't know what's going on with this. I don't know. Okay, back. Okay, so which are the highest priority areas? And from that, we generate relevant deforestation alerts that are relevant for the client. So a little bit more about the baseline. We use a baseline that goes back to the 1980s to make sure that we really know that we're actually looking at forest and not just at plantation clearing. And that's very important to know that you're looking at the right thing. Two other important topics are accuracy and consistency. And what we do is we combine Landsat, Sentinel-1 and Sentinel-2 data by using an algorithm called Bayesian iterative updating. And so these are 3 different satellite programs, and 2 of them are optical, so Landsat and Sentinel-2, and 1 of them is the radar satellite, that's the Sentinel-1. And using that combination and the algorithm, we can detect changes within forest areas in near real time with a more than 95% accuracy over the entire world. So a little bit about this Bayesian iterative updating. I can't go really in depth because I don't have that much time, but this is something we developed together with the University of Wageningen, and it uses something called Bayesian statistics to calculate the probability of change. And this says as much as we know what forest looks like for a certain satellite. We know what areas that are not forest look like for a certain satellite, and we get the statistics for these areas. Then when a new image comes in, we calculate the probability that it belongs to a forest area or a non-forest area. And using that probability and new incoming images, and also other satellite images, we can stack all these probabilities to determine whether an area has actually changed or not. So this is very short what this is about, but we published a blog earlier this year, and the link is below, and we can share it later. But this same blog was also actually published on Geoawesomeness. So I see the link coming into the screen already. Very nice. Thank you. All right. What else is important? So for consistency, we think it's very important to use open data because you want to be able to do comparisons of deforestation data 2 years ago with deforestation data of 5 years in the future. And these open data programs, such as the Landsat program and the Sentinel program, they have a guaranteed data continuation over the coming years to come. We do use very high resolution data, so commercial data, but we mainly use that for determining the accuracy of our algorithm, both in space and time. And we think it's very important that we are open about which methods and algorithms we use. So we don't want to use black box algorithms because we want to be open towards our clients and use published methods that they can actually verify what we are using. So a little example of what that looks like. I have here a satellite image, a Sentinel-2 image of an area in Ghana. Ghana is very notorious for haze and cloud cover. And here there's an after image. So we see there's a lot of deforestation going on in the middle of the image. There's some road building, and there's some selective logging also a bit to the east of the road. Now, if we put our change detection algorithm over this, you can see here in green, you can see all these changes nicely detected, the big swath in the middle, also the road, and then of some of these selective logging patches as well. And if we compare this to another data set, which is called the GLAD data set, which is an open data set, which only uses Landsat data, so only optical data, no radar data, then you can see that they pick up a lot less. So here in orange, you see on top of our changes, you see the GLAD changes, and you can see it's just minimal, just a few pixels that that this algorithm detects. Again, about this, we wrote a blog. This one was not published on Geoawesomeness, but is on our website. So we can share the link. I hope it pops up in the screen again like it just did, and otherwise we'll share it later. All right, so we have a lot of data. We know where deforestation is happening, but somehow we need to put this into context. And what I'm going to show now is a series of images and data that we use in harmony to create this whole context. So first is a radar image that I said this is an image that we use for the change detection. And this is also what I mentioned before. This is a baseline where you can see the forest, you can see the plantations. and this in this particular case is then of 2015. We can then add additional information such as peatlands, which are important for NDPE agreements, which is that there's no, how do you say that? No further continuation of planting palm on peatlands. And we can add on top of that a map of where palm is already growing. Well, if we put on top of that all of our tree cover changes, then we can easily see where these changes are happening. But with this, still, we don't have the complete picture yet. What we really need to have to add is the concession and the mill data. So using these concessions and the mill data, we can create something that we call a supply chain model. So this whole model consists of these deforestation alerts that we have on the left, and how they go to mills, and how they go to suppliers, and how they ultimately go to manufacturers, and how they ultimately end up in the supermarket. So we can trace deforestation alerts all the way through the supply chain, and we can relate them to different mills, suppliers, and manufacturers. And this is all very nice to have all this kind of information and insights, but we also think wisdom without action is an empty shell. If you just print it out and you put it in a frame and you put it on the wall, very nice, super beautiful, but no one benefits from it. So we think that we need action. So we think that there are three major types of actions that can be taken using our monitoring system, which is proactive response via early warning. You can report progress towards zero deforestation, and you can do reactive grievance responses. I will have a series now of questions followed by some insights that we can provide, and then which kind of actions can be taken to it. So first up is where in my supply chain is currently deforestation ongoing. So where is deforestation happening maybe a week ago? And we have an app for that, an online app, which shows you in the blink of an eye how much deforestation is happening, where this deforestation is happening, and can easily guide you to areas that are of highest priority. We show deforestation, whether it's happening inside a concession, whether it's outside a concession, if it's on peatland, if it's in a protected area, all these kind of things, the distance to processing mills, etc. So which actions can a company then take? So the company can log high-risk alerts that come in as grievance issues, so they can store them in their systems to deal with them as they come in also from other types of systems. They can send in field teams to investigate who's responsible for the clearing and record follow-up actions. And buyers can also decide to do stop work orders and monitor that this actually happens to suppliers. And this is actually the question that we started with. Is my supply chain deforestation free? Or which percentage of my supply chain is deforestation free? And basically which percentage of my peanut butter jars is deforestation free? And using our supply chain model and insights that we create from there, we can look back into history and see how this evolves over time. So how does your deforestation freeness level, as it were, evolve over time? So we can say very specifically for a certain area, we can say, okay, for Aceh, for instance, in 2018, the supply chain was 45% deforestation free, whereas a year later it was 66%. So these are very concrete numbers. So what can you do with that? You can inform sustainable sourcing contracts. So if buyers want to impose that on their sellers or something like that. And then as a last question, where in my supply chain is the biggest source contributing to deforestation risk? And this is then not about what is happening now, but what has happened over a longer period of time. And with our supply chain model and the deforestation risk monitoring, we can look at suppliers, we can look at mills, and we can look at concessions, and we can sort them. We can look at the number of deforestation events that happened. We can look at how deforestation free they are and how that evolves over time. So which actions can you link to this? You can engage with a supplier and you say, hey, why are you sourcing from mill 1, 2, or 3? And in turn, maybe the mill can take action whenever necessary. So I think 15 minutes is never enough, and I have no idea if I kept within my time or not, but I think this is basically what I wanted to share with you. And concluding this, like with the Satelligence supply chain model and deforestation risk monitoring, you can take immediate action towards a deforestation-free supply chain. So with that, I wanna finish and welcome any questions that you might have for me.